Hello, here's a video that shows you how to analyze the gel filtration chromatography data that you received last week. What's shown is the spreadsheet I sent you. In the first column are the test tube numbers 5 through 22. Those are the test tubes that came off the column. The second and third columns show you absorbances. The first one is at 650 nanometers, which reads blue, and this is where the blue dextran came out from the column. So these test tubes are all slightly or largely blue. Blue dextran's a really large molecule, so it comes out of the column first. It can't fit into any of the pores of the beads, so it just goes around them. The second absorbance is 440 nanometers. This is for yellow absorbance. So all of these values are the yellow test tubes, and it's where the DNP aspartate came out. That's a very small molecule, slightly bigger than 1 amino acid. So this can go through all the pores in the beads, and it'll take a lot longer to come out. All the ones in the middle that say not determined are the colorless test tubes, and we didn't read those because they had no color. So the first thing you have to do is make a plot of these absorbance values versus milliliters of elution. These numbers are test tube numbers, so it's better if you convert them to milliliters. And if you see this here, you realize that every test tube has about a 2 milliliter volume. So all you really have to do is multiply these by 2. So for example, 5 times 2 equals 10. So the next one is 6. So 6 times 2 would be 12. 7 times 2 is 14. So those are all the milliliters of elution. So go ahead and convert all those, timesing by 2. And your very last one will be 22 times 2 is 44. So your X values will go from 10 to 44. So let's make that plot. It will look something like this. We're going to cover up the second plot first, so just focus on the first one. So we have absorbance on the y-axis. We have milliliters of elution on the x, and this will go to 44, which would be here. And if you plot it, let's do blue for the blue dextran. It will look something like this. And then we'll do yellow for the DNP aspartate. It'll look something like that. So in the middle, there will be nothing because there's no color. These are the yellow tubes, and these are the blue tubes. And this will be the DNP aspartate. So then the reason we do this is because we want to find the volumes for the K average equation. So you take the peak of the peak, drop a perpendicular down, and that will be your VO, the void volume. And then you'll go to the other peak, which is the DNP aspartate, get that volume, and that will be the VT, which is the total volume of the column. So those are 2 parameters you need to solve the K average equation. The next plot you need to make is the activity versus Bradford data plot. And in that case, we're looking at this part of the spreadsheet. So here's our Bradford assay. These numbers tell us where the protein came out in the column. So in this case, this is test tube number 6. If you look over here, this is number 6. You go across. The first value we get is test tube number 6. So this would be 7, 8, 9, 10. So the bulk of the protein came out in 7, 8, and 9. And then for the activity assay, we have these values, and the largest value is here, which is test tube number 9. So go ahead and plot those values, 595 and 410 versus, again, elution volume. So that's my next plot. So then we will go ahead and plot our Bradford absorbance. So absorbance will be on the Y. The Bradford absorbance will look like this. And then the activity absorbance will look like this. And since we want to find the volume it takes to elute the enzyme, it'll be this part here. That's the activity, so that's the 410 nanometer The other one is the 595 nanometer absorbances. So if we drop a perpendicular down here, this will be the VE, or the volume it takes to elute the enzyme that we're trying to purify. So that's the third parameter we need to solve the K average equation. But before we go ahead and do that, let's take a look at what we have here. So this is the peak of the protein, and this is the peak of the enzyme activity. Since those two peaks are different, what it means is the enzyme, which is the peak here, is separated from the bulk of the protein. So the bulk of the protein is all the protein on the column, and since those two peaks are different, the enzyme has come out later than the bulk of the protein. It means the column was successful at separating the enzyme from most of the rest of the protein. There's obviously still a lot of protein in with the enzyme, but the bulk of it has been separated out. So the column was successful in this experiment. Okay, let's go ahead and do the K average equation. So for K average, we need to take VE minus VO over VT minus VO. So let's say our VO from the first plot, which was calculated from that graph, is equal to S. And let's say our VT from that same plot is equal to R. And now we've just looked at the activity versus protein concentration plot, and we have VE equal to, let's say, Q. So to get K average, we just simply put those values in. So it would be Q minus S over R minus S. And let's just say that equals W. So once you do that calculation with your actual numbers, you'll get a K average. That's a number, we'll call it W. And then what do you do after that? You make one more plot, and that plot is K average versus the log of molecular weight. And where do you get the values you need to do log of molecular weight of and the K average? Those come from the lab handout, which is here. So here are your protein standards, here are those molecular weights, and here are those K averages. So you plot these numbers as your Y column, and then you take the log of all these numbers, log log of these numbers for the X column, and you will get a plot that looks something like this. It will start a little bit past 3, and it will end before 5, and it will have a slope in that direction. So those numbers you take right from the lab handout, just do the math, and then do a plot. Do linear trend line, get your Y equals mx plus b equation. The Y is equal to K average, and then the X is equal to the log of the molecular weight. So now we know from our previous plot and data, our K average is equal to W. So you just put W in to the equation, and that will equal mx plus b, solve for x, and x is then equal to log of molecular weight. So you'll need to take 10 to the x of x, or whatever your value is, and that will equal the molecular weight. So that is the first goal of this lab, to figure out the molecular weight of the acid phosphatase protein. Just remember you need to convert your x value back to a molecular weight since it's log of the molecular weight. The second thing we need to do is we need to calculate the activity of the purified, or at least partially purified, enzyme. So how do we do that? We go back to the original spreadsheet, which is here, and we find our activity assay. which has duplicate values for only one of them. So this right here is our values for your Suffidex fraction. And that would be the partially purified enzyme, acid phosphatase. So in order to get the activity and fill out that last line in your table, you will take these two numbers, average them, and then calculate your activity like you have in the previous lab. So you will take the Suffidex fraction values average them, convert to micromoles per minute like you did last week, and then divide by 0.050 mils enzyme again, because that's what was tested just like last week, and that will equal units per mil. So that will be the activity that goes into the table. The volume is for one test tube, so that will equal 2 mils. And then you get your total activity equals 2 mils times activity. And you will put that in the last line of the table. So this table comes from your handout, which should already be in your lab notebook. So you just have to fill out this last line. We've done the crude extract. We've done the redissolved pellet. Those were all done last week. You could also put your SuperNint data in here if you like, even though it's grayed out, it's fine. And then now for this week, you're gonna put this data in here. So the 2 mils goes here, the activity you calculate in units per mil goes here, and then total activity is always this column times this column to equal that. So once this lab is over, you should have the data for all of this. And then the lab we do this week, you will get the data for this part. So after this week, you can calculate the final purification fold and complete your table. I hope that helps. And if you have questions, just let me know.